Good day, everyone. This is another wonderful time to continue our series of lectures on Introduction to Computers, and today we shall be looking at classifications of computers. You will learn about the variety of computers and how they can be classified according to the type of data they process and their purpose. You will also learn about recent advancement in computer technology and how current thinking is shaping computer design. So at the end of this particular lesson today, you should be able to state the types of data processed, list the various classifications of computers, and explain the generations of computers. Types of data processed. The data processed by a computer can be classified into two categories. The first one is discrete and the second one is continuous. What are discrete data? These are countable data. That is, it has a specific value. For instance, you can count the number of people in your family. Continuous data, on the other hand, is a measurable data. It can take any value within a range. Values can be fractions or decimal point. Examples of continuous data include temperature of a given day, height of a group of individuals. Classifications of computers. Basically, we have four classifications of computers. We can classify computer based on the way data is processed. Recall that we have stated the types of data that we have. Also, we can classify computers based on purpose. We can classify it based on size, and we can classify it according to generation or age. Now, when we classify computer according to age, we are specifically looking at the modern era of computers. So we'll start with classification based on the way data is processed. Based on the way data is processed, computers are generally classified into three categories. The first one is analog, the second is digital, and the last is hybrid. What are analog computers? Analog computers are computers that use continuously variable physical quantities to represent and process information, while digital computers use discrete states. A good example of your analog computer is your speedometer, your car speedometer, or the analog thermometer. Whereas digital computers, common examples include your desktop computer, your personal computer, or your laptops. Hybrid computers, on the other hand, combines the feature of both analog and digital computers, allowing it to process both continuous, that is analog, and discrete, which is digital data, making it suitable for applications requiring real-time tracking and precise digital computation. A good example is your medical monitoring equipment that you see in the hospital. Classification according to purpose, based on what we use it for. Computers can be classified according to purpose in two ways. First is general purpose. Second is your special purpose. General purpose computers are designed to solve wide variety of problems in different fields. As a matter of fact, you can reprogram it. For instance, my PC, I can decide to install another version of OS on it, and it will accommodate it. And I can install specific software. For instance, I'm teaching you now, and I'm using Microsoft PowerPoint, which is one of the suite of Office applications. You have Microsoft Word, Microsoft PowerPoint, Excel, and so many others. So, and equally, I can share this video with you on Zoom, or other platform. So I can use a combination of applications to share this lecture or class with you. So they can be used for different purposes, such as record keeping, word processing, graphical applications, and so many other applications. So computers that gives you the ability to do this are called general purpose computers. Now, special purpose computers are used for specific applications. Usually, you cannot alter the programs that are involved, that are installed on these computers. For instance, air traffic control computers at the control tower at the airport. It is fixed, and usually when you have issues, maybe problems with this kind of computer, oftentimes you have to seek the consent or the support of the manufacturers. Classification according to size, based on how big they are. We have microcomputers, mini computers, mainframe computers, and supercomputers. The way in which the order which I've listed them determines the size. So microcomputers are smaller in size to mini is smaller to mainframe, and mainframe is smaller to supercomputers. Microcomputer uses a microprocessor, and it is the smallest in size, whereas mini computers are medium-sized computers but more powerful than micros. It can actually support multi-users ranging from 10 to about 20 people. And mainframe are actually larger than mini, and they can support more users than minis. Supercomputers are actually far bigger than any of these three. Supercomputers are the fastest, the biggest, and the most expensive modern computers. They are actually used for serious mathematical calculations such as weather forecasting, real scientific computations, and a whole lot of space exploration activities. Classification based on generation, which is the fourth classification and the last. Now, we can broadly classify based on generation into 4 categories, and sometimes we can classify it into 5. So the fourth and the fifth are almost the same, just a little difference in advancement. The first generation computer existed between 1942 to 1959. Basically, it uses vacuum tubes for processing and punch card for input or output operation. Now, the unique thing about vacuum tube is that it's big. Those computers in this era are very big, and because it's big, it's expensive, and it uses a lot of current to power it, and because of that generates a lot of heat, and oftentimes they burn out, making it readily, and it's actually very tedious to actually identify and isolate the one that has burned for replacement. So it consumes a lot of electricity, and because it burns out readily, computer in this era are actually not that reliable. Second generation between 1959 and 1965 basically uses transistors for processing, and computer in this era actually are much smaller because transistors are much smaller than vacuum tubes. They are more reliable, they consume less current, and they are more stable. They cost less. They are capable of batch operating system. Batch operating systems can be installed on it, and they are very fast. A good example is the Honeywell 400 and IBM 7030. The third generation is between 1965 and 1975. Because of the success of transistors, the goal now is to miniaturize the computer processing, and a lot of transistors are integrated together, coupled with a few other components like capacitors and transistors, making it what we call integrated circuit. And computers in this era are actually faster, smaller, and more reliable, easier to update. So a good example is your IBM 360. Next is the fourth generation, which actually uses large scale integration or very large scale integration, and um, millions of transistors can be integrated together, and computers in this era are actually smaller, so the miniaturization has also been enhanced, making computers smaller. They are now equipped with a graphical user interface, making it more flexible to use. They are affordable to buy, they are smaller and affordable to buy, and easier to update. A good example is your Apple II, Cray 1 and 2, which are actually supercomputers anyway. So, and the fifth uses ultra large scale integration, which is the ULSI technology. They have large capacity hard disks, and most times equipped with RAID technology, and they can be used with powerful servers, internet, and cluster computing. They are powerful, very powerful. Out of all the generation, is the most powerful. They are cheaper, and they consume less current, making it very reliable. And rapid software development is possible with this generation of computer. Common examples are the one manufactured by IBM and Pentium. And now today you have common processing units, CPU produced by Intel, which can be your core, dual core, Core i3, Core i5, or i7. We have the Athlon series by AMD, and various CPUs by different manufacturers. A quick recap of what we have learned today. Data can be classified into two categories, the discrete and continuous data, and also we mentioned the various classifications of computer. We mentioned classification based on the way they process data, which are the analog, the digital, and the hybrid, based on purpose, the general purpose, and the special purpose or specific purpose computers. And we have classification based on size, which are micro, mini, mainframe, and supercomputers. And classification based on generation, we have first gen, which uses vacuum tubes, second gen, which uses transistors, third gen, which uses integrated circuit, fourth gen, which uses very large scale integration, and fifth, which uses ultra large scale integration. And as they are evolving with the generation in this modern era, so they are fast, more compact, more reliable, and easier to buy. So thank you. Till we meet at another time again, have a wonderful time.